10th Physical Science, Lesson Chemical Bond, Topic Hybridization. Hybridization means intermixing of atomic orbitals of equal energy present in outer shell of the atom and redistribution into same number of orbitals with equal properties like energy and shape. So every element has atoms. In the atoms, outer shell of electrons intermixing and redistribution into same orbitals with a properties like energy and shape, that is called hybridization. For example, here beryllium chloride is there. So here one beryllium and two chlorine atoms are there. So here we can see beryllium has a 4 electrons. Electron configuration 1s2 2s2. When these orbitals are intermixed and distributed, then the beryllium get excited state. So in the first, before intermixing, in the ground state the electrons are 1s2 2s2. So in the orbitals electrons are paired electrons. So after intermixing, when the electrons are redistributed into the orbitals, so the electron from the 2s2 goes into the p orbitals. So now the electrons are unpaired electrons. In the 2s, one electron is there. Before 2 electrons are there in 2s orbital, next excited state in the orbital 2s orbital, one electron is there. Another electron goes to the p orbital. 2px orbital, one electron goes in this orbital. Now, in the excited state, beryllium has a 2 unpaired electrons. Next, chlorine. So, how many chlorines are there? 2 chlorines. BeCl2. 2 chlorines are there. First chlorine electron configuration 1s2, 2s2, 2p6, 3s2, 3p5. Second chlorine electron configuration 1s2, 2s2, 2p6, 3s2, 3p5. So these electrons are equal to the atomic number 17. When we count the electrons, last outer shell electrons, 3p5. So in the p orbitals, first paired electrons are there, second paired electrons are there. In the last orbital 2pz, one electron is there. In second chlorine also, outer shell 5 electrons are there. First paired electrons, second paired electrons, and last single electron is there. Okay, so beryllium unpaired electrons 2s1, 2pz1, 2s1, 2pz1, and chlorine has the unpaired electrons 3pz1, 3pz1. So here lone pair electrons, unpaired electrons are this. So between these sp orbitals and 3p orbitals overlapping each other, beryllium and chlorine 2s2, 2pz1 and 3pz1. So orbitals overlapping each other and forming bond, sigma bond between sp and p. Sp means beryllium, 2s1 2pz1, and P means chlorine orbitals. So between the beryllium and chlorine, orbitals are overlapping each other. Then the bond sigma is formed between the sp and p orbitals. So here we can see beryllium between central atom, and the bond formed beryllium and chlorine. Okay. In ground state, beryllium electrons can be seen as a paired positions. In a paired ground state, paired positions. And excited position, beryllium 1 electron in 2s2 orbital goes in 2px1. So here we observe here. From 2s2, the electron goes to the 2px1 orbital in the excited state. These orbitals are intermixed and distributed as a hybrid orbitals. So these sp orbitals of beryllium overlap with each chlorine atom with its 3pz1 electron, 3pz electron, unpaired electron orbitals. Beryllium formed the two identical beryllium chloride bonds, sigma sp p bonds. Next one, between beryllium chlorine, the angle is 180 degrees. Both the bonds are same strength. So here the shape is linear and the angle is 180 degrees. Next, formation of boron trifluoride molecule. Boron atomic number 5, electron configuration 1s2 2s2 2px1 ground state, and excited state 1s2 2s1 2px1 2py1. So here also in the excited position, the paired electrons one goes to the another orbital. 2s2, from the 2s2 orbitals, the electron goes to the another orbital 2p1. So here 3 unpaired electrons are there, 2s1 2px1 2p1. Okay. So there is an intermixing of 2s, 2px, 2py orbitals and a redistribution into sp2 hybrid orbitals. These are hybrid orbitals. Next, fluorine. Fluorine electron configuration 1s2 2s2 2p5. So the electrons filled in the orbitals like this. Second, fluorine also arranged in the orbitals. Third, fluorine electrons also arranged like this. So in the last orbital, unpaired electron is there. These 3 sp2 orbitals separated by minimum repulsion, and the angle between orbital is 120 degrees. Now 3 fluorine atoms overlap their 2pz orbitals containing unpaired electrons. The 3 sp2 orbitals of boron contain unpaired electrons to form 3 sigma sp2 and p bonds. So around the boron, fluorine orbitals are overlapped each other. Boron sp2 orbitals, boron sp2, 2s, 2px, 2p, sp2. sp2 orbitals overlap with the p orbitals. So, in the p last orbitals unpaired electrons. So, these three unpaired fluorine electrons. Okay, so p fluorine p orbitals overlap with the sp2 boron orbitals and form a sigma bond between boron and fluorine orbitals. And between the boron and fluorine, the angle is 120 degrees. Okay. Next, formation of ammonia molecule. Nitrogen electron configuration 1s2, 2s2, 2px1, 2py1, 2pz1. So, 3 unpaired electrons are there. 2s2 and 2px1, 2py1, 2pz1 orbitals of nitrogen intermixed and redistributed into 4 identical sp3 orbitals again. One orbital get pair electrons. 2s2, next other 3 get 1 electron each, 2px, 2py, 2pz, like this. Now hydrogen atoms overlap 1s orbitals. Hydrogen has already 1s orbitals are there. So these 1s orbitals with nitrogen to give 3 sigma s sp3 bonds and angle 109 degrees to 8. It decreases by repulsion of greater lone pair bond pair. The repulsion between the lone pair and bond pair. So they got angle 107 degrees 4h. So here the orbitals of and nitrogen intermixed and distributed into 4 identical sp3 hybrid orbitals. Again, the orbitals got paired electrons and another electrons as a 2px1, 2p1, 2pz1. Next, so these 2px1, 2py1, 2pz1 orbitals overlap with the hydrogen 1s orbitals. Okay. When the hydrogen 1s orbitals overlap with the p orbitals, so automatically the angle 107 degrees 48 formed between the nitrogen and hydrogen. Next one, the repulsion formed between the lone pair electrons and bond pair electrons. But the repulsion is greater than lone pair to bond pair. Okay, so the 3 hydrogens are throws below the nitrogen. Next one, shape of water molecule. In the water, what elements are there? Oxygen and hydrogen. Oxygen atomic number 8, electron configuration 1s2, 2s2, 2px2, 2py1, 2pz1. Hydrogen atomic number 1, electron configuration 1s1. In the oxygen, the electrons, p electrons, first orbital paired electrons and second, third orbitals as a unpaired electrons. 2s and 2px, 2py and 2pz orbitals are intermixed and redistributed into 4 identical sp3 orbitals. So these 2s2, 2px2, 2py1, 2pz1, these are orbitals intermixed and redistributed as into these orbitals. And as it is get 2s2, 2px2 pair electrons. After intermixing, the distribution electrons get position of as a 2s2, 2px2 pair electrons. Next to 2py1, 2pz1 as it is get 1 electron. These orbitals overlap with the s orbitals of H atoms. 2p1, 2py1, 2pz1 electrons of oxygen overlap with the 1s orbitals of hydrogen atoms to give sigma 2 sp3s bonds and angle between oxygen and hydrogen 10431. So when oxygen overlap with the hydrogen, the angle is formed between the 104 degrees 31, and on the other side paired electrons are there, and these are lone paired electrons. Bond pair electrons also there. So here also the repulsion is greater between lone pair electrons and bond pair electrons. So here also the hydrogen comes together below the oxygen. So all these about the hybridization. Hybridization means the orbitals of atoms intermixed and redistributed into the orbital as same energy and same. Okay.